Chemical Kinetics, Class 12. Rate law of composite reactions. What is the meaning of composite reactions? Composite reactions are those which are completed in more than one elementary steps. For example, if you see NO2 when joins with carbon monoxide, it forms NO and CO2. This is the reaction. But this reaction won't take place in one step. The step 1 is NO2 joins with NO2 to form NO3 and NO. This is step 1. Second step is NO3 will react with carbon monoxide to form carbon dioxide and NO. NO2 as it is. So finally you can say this NO3 is and NO2 can be cancelled. So finally you can see here NO2 plus CO gives us NO and CO2. So NO3 is the intermediate, right? And this is step 2. Now the question is, which is fast step and which is slow step? So in such kind of things you must know the mechanism. And in this reaction, when NO2 reacts with another NO2 to form NO3 and NO, which we are calling step 1, this step 1 is the slow step. And see here, this is an arrow showing single side. And next NO3 when treated with carbon monoxide forms NO2 and carbon dioxide. Now this we are saying as step 2. This is fast step. And slow step is rate determining step. So we need to consider only rate determining step. So this is no need to be considered. You need to consider this only. And the answer will be, now rate is equal to some constant into concentration of NO2 to the power 2. Okay, this is experimentally also verified. So when more than one step is there, you need to go with the slow step. Okay, now if this was the slow step, then the things will go something different. That example I will take you. So composite reactions are those which are completed in more than one steps. This is example 1, this is example 2. समझ में आ गया ना? Right. Now we'll see one more example. Here I will take 2NO plus F2 gives rise to 2NOF. This is the reaction. Fine. And its mechanism, if without mechanism you can't say composite reactions. You should not say that 2 is there, here 1 is there, so order is going to be 3, rate is equals to K into NO to the power 2 F2. No, you should not write. First of all, you should know the mechanism, and the mechanism is NO plus F2 gives rise to, see the difference here, what I am writing, NOF2. And this is very fast. Here both sides arrows I mentioned, that means it is in equilibrium. And very fast, very quick it is formed. Then NOF2 will react with one more NO to form 2NOF, right? This is our product, and this is the slow step. This one is the fast step and this one is the slow step. As we know, slow step is the rate determining step. So we need to write rate is equals to K into concentration of NOF2 and NO. Right? Now here is the twist. What the twist is? Very simple. This is our reaction and these are our reactants. So in the rate law or rate equation, only reactants are to be present. Only reactants are to be present. But NOF2 is an intermediate. This is an intermediate. So this intermediate should not present. This intermediate should not present in the rate law. So what we can do is, from this expression, you can write Kc is equal to concentration of NOF2 from chemical equilibrium concept, NO and F2, or you can write this is concentration of NOF2 is equal to Kc into concentration of NO into F2. This NOF2 value now you substitute in this expression. So how it is going to be? Rate is equal to K into, in place of NOF2 you are writing this one, Kc into concentration of NO, concentration of F2, and this NO as it is. So K is a constant, Kc is a constant, both are constants, only you take one more constant or K, no problem. And NO and NO, so it will be NO square and F2. So this is the rate. Hey sir, what are you doing sir? Directly also NO square and F2 only will come. Na? That is true. But luckily you are getting like that. You have to solve like this. So these are the methods to write the rate law for the composite reactions. Okay. If the slow step is present with the original reactants, there is no need to change anything. But if the slow step is containing intermediates, then you have to write the concentration term of the intermediate with the help of equilibrium constant. Then that can be substituted here and you will be getting this law. This is rate law and the explanation about rate law of composite reactions. Thank you. This is your Lakshma sir.